Hello, Mr. Lee here. Today's video, I'm going to show you guys just two examples from each of the Khan Academy exercises in your assignment. Okay, so watch closely. Pause the video if you need. I also have a split screen with Desmos. It'll come in handy, right? So use this resource as you need. All right. So the first exercise: evaluate functions. Directions say find the output y when the input x is 30. Okay, so fancy term for your x values are inputs. Fancy term for your y values are outputs. Okay, so inputs x, outputs y. So this is how this works. It says y is equal to 14 minus 0.5x, and it says I want to find the y value, or your input, when I have an x value of 30. Okay, so this is this goes back to last semester when you're dealing with just equations, tables, and graphs, trying to figure out what y values are produced when you have a specific x value. Okay, the only difference I think is we're actually using these terms inputs and outputs. Okay, but really it's just x values, y values. So if I have an x value of 30, instead of y being equal to 14 minus 0.5 times x, it's going to be y equals 14 minus 0.5 times 30, right? So you can evaluate this. Half of 30 is 15, right? You can also say, oh, 14 minus 15. So the evaluated number is -1, right? So the y value should be -1. If I plug in or substitute the value of x is 30, you will get a y value of -1, okay? Let's show one more here. Find the output k, or y value, when the input t is -7, or x value. Okay, so they use different letters here, but really you can think of it as x and y. But let's just follow the lettering, right? The input t is -7. So look at your equation here. K is equal to 10t minus 19. The t value gets changed to -7, right? So instead of 10 times t, it's 10 times -7. So I'm going to follow the same rule. Call the function. 10 times a -7 is my new t value. I still have to subtract 19, so that simplifies to a -89. Okay, if you want to see the simplified version with some steps, right? 10 times -7 is -70. Then I still subtract 19, it's still -89. Okay, so that final simplified evaluation of that output value is -89. Okay, so that's all for that one. Let me close that. See if I can make this, enlarge this a little bit. There we go. So we're going to go to the next one, evaluate functions from the graph. So we're still going to be thinking inputs and outputs, x values and y values, right? So same directions, but we're just in the context of a graph now. So find the output y when the input x is -9. So imagine you are graphing points. I have an x value of -9. I'm going to start my origin, go to an x value of -9. I want to find what my y value is on that graph when I have an x value of -9. So you're just kind of reading the graph here. The blue graph will have a point at -9, comma -1. Sorry, -9, comma +1, right? So -9, +1. So when your x value is -9, your y value is +1. That's all it is, right? Inputs, outputs, x values, y values. Let's do one more. So again, find the output y when the input x is -5. So basically, what's the y value when your x value is -5? I'm going to go back to my origin. X value of -5 is right here. Let's read where the graph is with an x value of -5. It goes all the way up there. If you read it closely, it should be a y value of 7. Okay, so -5, comma 7, or in other words, your output value is 7 there. Okay, so that's all that is. And then your last exercise, we did a lot of this in the past couple days with recognizing functions from graphs. Vertical line tests with these graphs is the best way to go. So think about, hey, does every x value have exactly one y value? So this one's already a vertical line. You have multiple y values for that single x value of 6, so that's no good. Let's just do one more real quick. This one's crazy. If I draw a vertical line anywhere, right, it's going to hit multiple places. So that's already a no. Okay.